In this video we'll have a look at developing the formula for the area of a sector where the angle at the centre of the circle can be expressed in degrees and radians. Following on from that we'll have a look at two examples. So let's look at how we develop the area of a sector given an angle at the centre here, theta. So we know that that's some fraction of the circle, and there are 360 degrees in a circle, and the area of a circle formula is pi r squared, where r is the radius. So that angle over 360 represents the fraction of the circle that that sector occupies, and we multiply that by pi r squared. Now we can modify that formula for radians. What we'll do is we'll change the 360 degrees to 2 pi radians. So the fraction of the circle now is expressed as an angle in radians. Now we can do some simple cancellation and divide pi on the top line by pi on the bottom there in pink, and that leaves us with theta on 2 multiplied by r squared. Now dividing by 2 is the same as multiplying by 1/2, so I'll rearrange that formula so the area of the sector is 1/2 r squared theta. Let's look at an example now applying the area of a sector formula. So in this case we want to find the area of a sector where the radius is 5 centimeters and we've got an angle of 120.5 at the center of the circle. Now we've got a choice here. We could use the formula that we had right at the start where we've got an angle as a fraction of 360 degrees, and that would be perfectly okay. But if we're going to use the area of a sector formula, which is 1/2 r squared theta, we must express theta in radians. Let's first of all have a look at a diagram of a situation. We can see here about 1/3 of the circle has been shaded. Now we'll convert 120.5 to radians by multiplying it by pi over 180. And when we do that, we get an angle measure of approximately 2.10 radians. So now we can use our formula. So the area is equal to 1/2, and the radius is 5, so it's 1/2 of 5 squared multiplied by 2.10. And what we'll do is we'll retain the accurate value of 2.10 from our previous conversion into radians rather than round it off and use just 2.10 in the calculator. And when we do that, we get an answer which is approximately 26.29 centimeters squared. For the next example, it might be a good idea to pause here, read through the problem, and think about the strategy you might employ before you actually have a look at the solution. As with many solutions, drawing a diagram is often a good way to determine what information you have and what you need. So drawing a sector, we can see that we haven't got the angle inside the sector, so we'll express that as theta. We have got the radius of the circle, that's 3 centimeters, and we have got the arc length, which is 5 centimeters. So we can use the length of the arc to determine the angle. That formula is L equals r theta. So we can substitute in 5 for the length of the arc, 3 for the radius, and from there determine the angle to be 5 on 3 radians. Of course we need that in radians to use the area of a sector formula, which is 1/2 r squared theta. So in this case we've got a radius of 3, and we'll sub that in for r squared, so we've got 1/2 3 squared multiplied by 5 on 3. Now we can determine this answer exactly, so without using a calculator, and that answer comes to 7.5 centimeters squared.